Okay, good morning guys. This is section 5.5 and we're going to talk about multiple angles. And in this section they took everything out of the curriculum except the double angle formulas. So that's what I'm going to focus on, the double angle formulas. And they are all right here, and of course you're going to have the formula sheet that I posted on EDSB to use during your test as well as on your semester exam. Okay, so these are all the double angle formulas for the sine, the cosine, and the tangent. Remember that the cosine has three different renditions of that formula, and you're going to use whatever one is most convenient for you to use. What are we going to use them for? To solve equations, to evaluate functions, and so forth. So I'm going to go over the examples of what you can expect on the test. And one of them, of course, is equation solving. And I said in an earlier video that the brunt of this test is on solving equations. So what I want you to do whenever you see an equation, I want you to scan it real quick from left to right and say, oops, that's not the sine of x, that's the sine of a multiple angle 2x. And I know that I'm going to need to use a double angle formula to expand that out and clean it up. The other thing I know is that I have a cosine here and a sine here, and I can't have two different trig functions. So my goal at the end is to maybe, if I can, turn it all into sines or cosines, or a product of two different factors that I can solve pretty easily for. So, noticing that I need a double angle for this formula, I'm going to bring everything down and expand this out according to the double angle formula. Now remember that for the double angle formula, the sine of 2 times an angle is equal to 2 sine u cosine u. So my angle's in terms of x here, so I'm just going to take this little piece here and write it as 2 sine x cos x. Okay, popped it right there. And if I distribute this 2 times 2 gives me the 4. So nothing's really changed from this line to this line other than I multiplied the 2's together. And what I end up with is, I've got a couple of cosines now and a sine. And it's going to be really hard to change this sine into a cosine. In fact, it can't be done. So rather than that, I'm going to factor out a 2 cosine x, right? 2 is common in 2 and in 4, and a cosine x is common in this term and this term. So I'm going to factor out 2 cosine x, and what I'm left with is 1 plus 2 goes into 4 twice, and the cosine x's would cancel, so I'm left with a sine of x. Now I have the product of two factors, so I can set each factor equal to 0 and solve. Well, the cosine of x is equal to 0, we know at pi over 2 and 3 pi over 2. Over here, a little bit more work. We have if I subtract 1 from both sides, we get 2 sine of x equals negative 1. Dividing by 2, sine of x equals negative 1/2. And we know that the sine is negative in quadrants 3 and 4, and so that's going to happen at 7 pi over 6 and 11 pi over 6. And so how you can write your examples, now look, these are pi away from each other, right? So I just put pi over 2 plus n pi to cover both these angles, right? If n is 1, I plug a 1 here, pi over 2 plus pi gives me the 3 pi over 2 that I need, right? If I add a 2, I get back to pi over 2 and so forth. So doing this is just going to ping pong those values back and forth between pi over 2 and 3 pi over 2. So that covers everything. And here I'm just going to add a 2n pi for each one of those. And I'm done. A simpler version is this little problem right here. Sine 2x minus sine x equals to 0. Again, if I scan from left to right, I notice this is not just an x anymore, it's something times x, namely a 2. So I'm going to use my double angle formula for the sine, which is 2 sine x cos x. Going to bring that down, set it equal to 0. And conveniently, I've got a sine in both of these terms, so I can pull out a sine, factor out a sine, and rewrite what's left. Well, what's left in this term is 2 cosine of x, bring down the minus, and what's left here by division is 1. So now I'm going to set each one of those little factors equal to 0 and solve. Well, we know that the sine is equal to 0 at 0 and pi. And a little bit more work again on this one. I've got to add 1 and divide by 2, so I did that in one step. And I know that the cosine of x is positive 1/2 in quadrant 1 and in quadrant 4. So pi over 3 in quadrant 1 and 2 pi minus pi over 3, which gives us 5 pi over 3 in quadrant 4. And again, how I wrote my solution is you know, this thing's gonna, we want this to ping pong back and forth between 0 and pi. Think of your unit circle. So I don't want to put 2n pi because it's just going to keep me taking me back, you know, to one or the other. It's going to skip one of the values. So, you know, when n is 0, I get 0. When n is 1, I get pi. When n is 2, I end up back at 2 pi. When n is 3, I get to 3 pi, which is pi. So anyway, a simple little n pi here will do. And then for these two, as you can see, I just added 2n pi to give me the general solution. Okay, another thing we can use this for, oops, and we did this exact example in class, but it's really important because you're going to see it on your semester exam, you're going to see it on the test. So find the sine, cosine, and tangent of 2x or 2 theta in this case, given some information. And the information that's given in this particular problem is that the cosine is 5/13 and that this angle lies in between 3 pi over 2 and 2 pi. And that's important because it's going to help you identify the quadrant. And you need to know the quadrant so you can, you know, so for example, if this is in quadrant 4, I know the cosine is positive there. And they gave me a positive value, so it makes sense. But if I have to find the sine's negative in quadrant 4. And the tangent's also negative because the sine is negative and the cosine is positive. And the tangent is the sine over the cosine. So this is super important so I don't make a mistake with my signs and then my arithmetic and then get the wrong answer. So the first thing we want to do is, again, make a triangle, put a little theta and x, whatever angle they give you, just throw it in there. And we know that the cosine is the adjacent over the hypotenuse, so I'm filling in these sides using that information. Then I can use the Pythagorean Theorem to find the missing side. Once my triangle's filled in, then I can start evaluating all 3 of these things that they asked me for. So the sine of 2 theta I know is 2 sine theta cosine theta, which is 2. Now if I look at my triangle, the sine is the opposite over the hypotenuse, so I put it in there. But you notice I have a negative because it's quadrant 4, and the sine is negative in quadrant 4. Times the cosine of this angle. Well, the cosine was given as 5/13, so I just popped that in there. And now it's just a matter of some multiplication, and sometimes you're going to have to simplify, sometimes not. In this case, you don't have to. But anyway, I have, you know, negative 12 times 5 is negative 60, times 2 is negative 120, and 13 squared is 169, and you're done. In the cosine, I did this 2 ways just to show you something. You can choose any one of the 3 cosine formulas for this double angle that you want to. Whatever makes you feel comfortable. It doesn't matter. You're going to get the same answer regardless. But I just want to show you something. I could go and choose this cosine, 2 cosine squared minus 1, thinking, oh, well, it only has a cosine, so I don't have to, let me just rewrite this triangle here. I don't have to keep referring back to my triangle or thinking too much or whatever. And that's fine. If I use it, I know the cosine is 5/13, so I pop it in there, squared minus 1. If I square 5/13, I get 25 169s. The problem is, many of you are just terrible at fractions, right? So this is easy. I can multiply this and get 50 over 169. But the big challenge is now we have to subtract 1 from that, and ooh, right? But you know, because I showed you. So I'm still just with a yellow marker, haven't been to the store yet. 169 times negative 1 is negative 169, and that's a positive 50, so when the signs are different, we subtract and we use the sign of the bigger number. So negative 169 plus 50 gives me negative 119 over 169, right? Alright, so we're done. However, when you use this one makes it easier a lot of the times. Not always, but most of the time it does. And the reason why is because so we have cosine squared minus sine squared. So let me just pop some things in and I'll explain, and you'll see why it's easier. Oh, look at this, I forgot my sine. So the cosine was 5/13, right? And we have to square that. And then the sine was negative 12/13, and we have to square that. When I square this top and bottom, I get 25 over 169, bring down my minus. When I square this top and bottom, any negative number squared becomes a positive, right? So I kind of don't have to worry about this negative in here anymore once I'm squaring it. Also, what it does This is 144 over 169 when I square it. You notice what happens, the denominators are the same. So now I know I have the same denominator, my fraction's easier. All I have to do is 25 minus 144 to get the numerator over the same denominator. So this one tends to be easier for students. Again, you use what you want to use, but I just wanted to bring that to your attention. Okay? Finally, we have to do a tangent. And the tangents, we don't kind of like those because there's a lot of arithmetic-y stuff here, and it's really easy to make a mistake. So I just brought the triangle down here. And the double angle formula for the tangent, of course, is 2 tan theta over 1 minus tan squared theta. So the tangent is the opposite over the adjacent, 12/5, and the tangent is also negative in quadrant 4. So I've got 2 times the negative 12/5 here over 1 minus negative 12/5 squared in the denominator. And when I multiply on the top, I get negative 24 over 5. And down here, when I square negative 12/5, I get 1 minus 144 over 25. Again, don't confuse this negative sign in the formula with the negative in here. This negative is going to become positive. All right, so it doesn't change this sign out here. Okay, so now I gotta clean this up some more. So my numerator, that's not going to change yet. That's going to stay the same. Divided by, and again, if I do 25 minus 144, I get negative 119 over 25. And I kept my negatives through here to show you, but you know, a negative divided by a negative is always a positive, so don't forget that. Or a negative times a negative is also a positive. So now, at this point, I want to get rid of this miserable fraction. So remember, we leave the numerator exactly the same. We write it down. We change division bar to multiplication, and we just flip this, right? We take the reciprocal of what's in the denominator and multiply it to that numerator. So again, a negative times a negative, or a negative divided by a negative, is going to give you a positive outcome. So my final outcome's positive. And here I can see, let me use the yellow marker, 5 divides into itself once, and it divides into 25 5 times. I know that's hard to see, but anyway, we have 24 times 5, or negative 24 times 5 is negative 120 over negative 119, and one more time, just to reiterate, a negative divided by a negative makes that a positive. That's it. Okay, last page for this video. Here's another one of those. So in this case, we want to find the sine, cosine, and tangent of 2 theta, or 2x, and they're telling us that the sine is 3/5 and the angle lies between 0 and pi over 2. That means it's a quadrant 1 angle, and I'm home free because I don't have to worry about negative signs. Everything's positive in quadrant 1. So I make my little triangle. I know the sine is the opposite over the hypotenuse, so I label the sides of the triangle, and by Pythagorean Theorem I can find the third side. Okay? So again, using our formula, the sine of 2x, or 2 theta it should have been, is 2 sine x cos x. And so let me just change this to x because it's bothering me. They should be the same. So that should be an x up there too, and this should be an x. They should all match. But anyway, I think you understand that. This is an x. I think I'm making it worse. So anyway, it's 2 times the sine, well the sine is 3/5, times the cosine, which is 4/5, right? And 4 times 3 is 12, times 2 is 24, and 5 times 5 is 25, and I'm finished with that one. For the cosine, I went ahead, and so again, I'm going to use this one because it tends to be a little bit easier for the purposes of fractions for students. If I take 4/5, which is the cosine, and square it, and subtract from that the square of the sine, that's going to give me 16/25 minus 9/25, and my denominators are the same, so I can just subtract the numerators and I get 7/25, and again, I'm done. The tangent, there it is, it's long, but I kind of tried to work it out step by step so I didn't leave anything out, so you can follow along. Here's our tangent formula. Well, the tangent is the side opposite, so let me bring this back up here. The tangent is the opposite over the adjacent, so 3/4. So I went ahead and plugged my 3/4 in to both pieces of the fraction here. 2 times 3/4 is 6/4, and down here it's 1 minus 9/16, right? Don't forget to square the top and the bottom of a fraction. ooh, we've got some, arithmetic here, some fractions. It's okay. 16 times 1 is 16, minus 9 gives us 7, right? So I went ahead and reduced this just to make the work easier. 2 divides into 6 3 times, and it divides into 4 twice. So I reduced this fraction to 3/2 on the top. And over here, of course, I did my 16 minus 9 back over the common denominator to get 7/16. And now that the top and the bottom are completely simplified as much as they can be, now I can rewrite this, right, as a multiplication problem. I leave the numerator alone and write it exactly as I see it. I change division to multiplication, and I flip this bottom number, and now I see, that 2 goes into itself once, and it goes into 16 8 times. And easily, without a calculator, I know that 3 times 8 is 24, and 1 times 7 is 7, and I'm done. Okay, so I hope that helps. I will try to do videos today for 5-1 and 5-2 again. But I do have some things that I have to do in the meantime, so I'll try to get those done and upload it tonight. Anyway, hope this helps, and I hope you have a great Saturday. See you later.